Okay then guys, let's have a little overview of this paper then. Try and simulate the thought processes you might go through if you're preparing for an examination, C4 examination in the near future. It's a good practice to have a little look at the paper at the beginning of an examination, perhaps take a minute or two, just to familiarize yourself with the content of the paper. There are many benefits from this. The first benefit is the fact that you can then choose which questions you would like to do first and give them some sort of order. But the other benefit is that you can actually then absorb the questions and watch every question is saying right at the outset of the exam. So even though you don't do these questions straight away, your brain is still working on them subconsciously. So you're actually saving time by spending just a couple of minutes at the beginning. So with that thought in mind then, let's have a little look at the paper then here. This is the summer June 2011 C4 examination for EdExcel. So let's have a quick look at the paper then, see if there's any nasty little questions contained therein. This is partial fractions. Nice easy question to do, isn't it? Partial fractions, that's a good question to start with. Shouldn't take too long. It's all arranged for you as well, so you haven't even got to guess what to write down there. 2, f of x is equal to this. Binomial expansion here, so again that shouldn't hold any horrors, no horrors for you in expanding this and simplifying each of the coefficient terms. So 2 is okay, so they're fairly user friendly so far. So the next one is 3. There's a bowl there with fluid in. Volume is given by this of height h. And then water's flowing into the bowl. So there's V. So find dV dH, that's simple differentiation. Water flows in, so that would be at a rate of, this is meters cubed per second, so dV dt equals this, doesn't it? And then it's asked to find the rate of change, so we want to find dH dt. So you're going to have to use rules of differentiation there to work out dH dt. So it shouldn't be too bad there for that one. Nice question really, in principle. So question 4, here's a curve here, described by this function here. So what have we got to do with this then? This is just trapezium rule question. So fill out the values for the function in question here and here. Then use the trapezium rule. So this is nice and standard, if not a little time consuming. Then use the substitution in the above equation to obtain this integral. So the nice thing is it's already there for you, so that doesn't need double checking. And then find the exact area of R, work out this integration. This is integration by parts. This would be V and this part component would be du. And you would just do the integration by parts and evaluate the integral. So that one looks a bit time consuming, probably a bit awkward. That particular question seems as though it's going to take a long time to do. So that might not be something you'd want to do, or leave to the end, not do at the beginning for sure. Find the gradient of this, 1 over y dy dx. X is 2, you can find out y. You can unwrap a logarithm, and that one is good. It's just a product here, again on the right hand side, isn't it? The left was log y, so that's a function of a function rule. 1 over y dy dx. So question 6 now is vectors. It's got 2 lines. Show they meet, so let the components x, y and z equal one another, and see if we can find a value for lambda and mu that's compatible for all 3 points meeting. Find the angle, acute angle. So we might find one angle, but you've got to make sure you get the acute angle there. This is a position vector B. Show it lies on L1, that's easy. And then the shortest distance from B to the line L2. So that looks like a triangle, right angle triangle there when you drop a perpendicular to a line. That's the nearest distance, isn't it? So again, that question looks fairly okay, with no major snags in it. The only time-consuming one was the one that we looked at on the trapezium rule. Here's a curve. Parametric equations. P lies on C has these coordinates. So it's probably find theta, isn't it? So that should be easy. Tan of 60. So pi over 3 is here. That's theta straight away. And then it's got some description about normals. Find the value of Q when the normal hits the y equals 0, the x-axis. Then it's going to rotate that volume. We work out the volume and in this form here. So again, time-consuming question, but doesn't hold any horrors for the most part, does it? Let's have a look at the next one now. So this is an integral, something to the minus a half, so that's easy to do, isn't it? That'll be something to the half, won't it? Then we solve this differential equation. We've done the hard work here, so to speak, and we can solve the differential equation with these initial conditions, and then we can rearrange it in explicit form. So that looks like the end of the paper then. Not too bad a paper there. Yeah, that is the end of the paper then. So it just remains for me to say all the best then, guys, if you're doing a C4 exam in the near future. Hope this little whistle-stop tour through the papers proved to be a little helpful. Basically, if you get time at the end of an examination, you've done all the questions, then double check what you need to in the questions and put a double tick on the questions. And then if you've still got time, of course, triple check the ones especially the ones you're most worried about as well, so you can eke out every last possible mark. So as I say, if you're taking a C4 exam in the near future, guys, I'd like to wish you all the best. Hope you do well, and hope you work hard and do as well as you possibly can. So hopefully I'll catch you in another revision worksheet. Cheers!